Hey, welcome to the first section of this course. My name is Parla Franco and this is Geometric Dimensioning and Tolerancing, Basic Level course. First things first, let's start answering the question, what is GD&T? GD&T stands for Geometric Dimensioning and Tolerancing. In other words, how to dimension and tolerance with geometrical controls. GD&T can be defined as an illustrated language for design and as a functional technique of production and inspection. It also helps manufacturers to reach sophisticated design demands in a uniform, complete, and clear manner. This unique system utilizes standardized symbols to describe the components in a language that is clearly understood by any manufacturer who is familiar with the standard. History of GD&T. Some books refer to the beginning of GD&T during the Second World War in Europe, when the Allies, in this case England, had problems in the production lines of war equipment. That was the case of some bombs and torpedoes, since there were many pieces rejected by not reaching specified dimension engineering drawings. However, when these rejected parts were tried to be assembled, they didn't have any problem, which proved the rejection of good parts by the Quality and Inspection Department. After a deep analysis, it was found that the reason for these rejections was the shape of the area of acceptance, which were a square shape when by functionality it should be circular. This is how the tolerance of position was born. Then it evolved to other tolerances as parallelism, circularity, etc. After that, the Army standardized it in the 1950s. At the top, we see the limit dimensioning method, which is composed basically by the plus-minus dimensions, mostly vertical and horizontal. At the bottom, we see the geometric dimensioning method, which is based on geometric controls, basic dimensions, and datums. Let's see the tolerances allowed in the part for each case. Limit dimensioning doesn't control the form of the part, so if the tolerances are wide, the form can vary as represented here. Notice also that the part is not fixed for measurement. Look at the tolerance zone delineated by this method on the hole. It has a square shape, which is not functional since the shape of the holes are cylindrical. Now, here are the tolerance areas of geometric dimensioning method. The shape of the part can be controlled by a geometric control of profile. Take a look at the hole. See how the tolerance zone described by this method has a circular shape, which is more functional for ensuring assembly between holes and counterparts. You can also see the restriction of the part is described by datums, a fundamental concept that we'll discuss forward. So, like we said, GD&T has more than 50 years. Even many people believe that GD&T is new. Starting with military standards from the World War II and passing into the hands of the ASME from the 60s up to the newest revision in 2009, although the most currently still used is the 1994 edition. So who is ASME? It is American Society of Mechanical Engineers, founded in 1980. It is responsible for issuing and updating some of the most used standards worldwide. Here are 3 examples: brace joint pressure fittings, pressure vessel safety standards, and types of applications of engineering drawings. All the ASME standards are available for general public through their website, www.asme.org. In the Y14 series, we can find all the engineering drawings standards for machine parts, metal and castings, etc. Here you can see the ASME Y14.3 related to multi-view and sectional view drawings, 14.6 for screw thread representation, and 14.8 for casting, forging, and molded parts drawings. The standard ASME Y14.5 dimensioning and tolerancing establishes uniform practices to define and interpret dimensions and tolerances to be used on engineering drawings. The two latest editions for this standard are from 1994 and 2009. The basic difference is that new concepts were added modifiers and rules, but generally are quite similar. Since this is a basic level course, we'll focus on the study of this standard for the 1994 edition because it's the most used. Section 1 of this standard provides definitions, basic rules, and general practices. Geometric tolerances are set from Section 2 to 9. GD&T today. Let's say an aeronautical company plans to launch a new model of an aircraft. The aviation industry always requires the highest standards of quality and therefore precision components. Because of competition, it is important to reduce the time of execution of the project relying on outsourced suppliers. The components have no problems in the CAD system, but at manufacturing, as we know, every process has variations. What if, when you get the components to the assembly line, they can be assembled? What is the fine for stopping a production line like this? Thousands of dollars per hour. That is why the aerospace industry benefits greatly from using GD&T among all those involved in the development of products and tooling. Some of the companies that promote the use of GD&T the most are the aircraft engines developers such as General Electric, Rolls-Royce, Pratt & Whitney, as they have highly critical parts subject to extreme stresses and temperatures. Here, we see the many components that form a turbofan, in this case the GEnx. These companies strongly promote knowledge of GD&T among their engineers, with many of them certified as the ASME. GD&T is a way to specify the design requirements, particular attention to the current function and the relationship between features. It's the best way to describe how the parts should fit each other and as their function should be only one, which is understood by all people throughout the process.